recording. Wi-Fi and USB debugging don't work together for some reason. Okay. Question for today. First question of the day. Word search. Given an n by n grid of characters code and a string word, return true if word exists in the grid. The word can be constructed from letters of sequentially adjacent cells, where adjacent cells are horizontally or vertically neighboring. Same letter may not be used more than once. Okay. Grid problem. Matrix. Well, matrix reminds me of breadth first search, single source breadth first search, and then multi-source breadth first search. For that we need a queue. Backtracking, depth first search, matrix. Okay, none of the things I mentioned. Well, we have matrix of alphabets. Yesterday, what question was that? Task scheduler. It also used alphabets, but they were really to confuse us there, because actually we'll talk about it later. This also uses alphabets. So the word is A, B, C, C, E, D. We need to check if this word occurs in this matrix. We have to find the path. The path should start from starting of this word, starting letter of the word, and we have to go along the path A, B, C, C, E, D. Yeah, we have to check each cell horizontally or vertically. Okay, same matrix, but word is different. And yeah, there the word exists in the matrix. Here the word is A, B, C, D. A, B. Okay, we find A, then we check. We go to right. B, but then there is C. Okay, first three letters are found. No B here. We can't go above. No B down. Left. We've already went to left. False. Could you use search pruning to make your solution faster with a large shardboard? That's optimization. Backtrack. How is this backtrack? How is it? Well, we go in one direction. If the word is not there, like eventually we would find out that the path is not right. Then we come back. We got back to the point where we saw another road, and now this time we take that road. Yeah, backtracking is basically multiple roads and you don't know which one is the right one, so you try each road and see it for yourself, find it for yourself. Here, how is it any different from other Q questions? Because I'm thinking of maintaining how is it different from other matrix questions? Because I'm thinking of problems. I'm thinking of maintaining a queue which will have the initial of the word we are looking for. So something like this is something where I iterate over the matrix, look for the word a. Well, if it's not there in the then if after the iteration if our queue is empty, then we know result answer is false. At the same time, we can have multiple initials, multiple initials in the queue, multiple starting points in the queue. In that case, uh, breadth first search. We just start looking immediately right after. Well, yeah, it seems like it reminds me of that problem, number of islands. So let's see, Boolean, check path. So for int I mode dot length I plus plus for j 0, j smaller than board's column length. J, I really like Kotlin now. This is so easy to do this in Kotlin. My plan is to once I have solved solved a good amount of questions, I will do them all over again in Kotlin. Okay. We wanna check if board is then we wanna take that path, check that path or return false. Now in this can I get some tricky example? I don't want solution, I just want Okay, we'll see. I'm thinking okay, character board, board, brightness. That's good. And something came up. Well, for the indices, let's start with I for row, column. We have already checked at these indices, and an index, maybe index of the. And I also need to keep a visited to keep track of the alphabets we have visited. All right. Can there be duplicates? Yes, there can be. Well, then how can I keep track of who visited index hash set is hash hash set um and I think we will need a queue. So if we will stop at here, A. From here we can potentially go to we can go to right, we can go down. If we go right, then B, and at this point we can go to right, we can go down, we can go to left. For that, to prevent that, I will add the index these indices into the set. But okay, but let's say okay, we are here. See, we have found the first three letters in the matrix. We are looking for B. We look to the right, we can't look back, we look down. Okay, those were the only valid places we could look at. And now ideally it would go back to the last found character, because this is not the right path. B was the last found character letter, and it should now start exploring the remaining paths of B if they were not explored before. If going to the from here, if going to the right was not the first path, no, if it was the first path, we still have one path more left. So we will go there. Okay. Okay. We can also do it with depth first search. Q uh, Q new linked list. Okay. And Q dot offer new int ing. That's right. Now if Q is empty, we return false, while Q is not empty. Q is not empty. Well, you get the index Q dot poll new R or index 0 C index 1 for we need to create a direction array 0 1. It's for going to the 0 0 0 0. It's for going to the right. This is for going to the left. This is for going up. This is for going down. Okay. Directions or int direction in directions. I want to say my new R is R plus new C is C plus direction. Now typical bound checking. Well, if new r has to be greater than -1 and new r has to be smaller than um, board dot size, board dot length, and new c has to be greater than -1 and new c has to be smaller than length. And the main condition, is that if we have a match word dot character at some sort of index um, is equal to uh, well, code new r new c, then we want to add that in our queue, that index, and new r new c. What's the catch here? I'm looking for a catch because this is so familiar. Q.own. B. Okay, so we are removing A from the pool after we have found a path. So we looked up, we looked down, we looked right, we looked left. Right is where we found the clue. Or let's imagine this: we look up, we look all four directions, no match for the next element. So we just well, we can check. We can check. A, B, C, D, 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 D. This is an easy case because we keep finding a path. Imagine if there was instead of F there was a C here. So if I'm at B and I can go to right and I can also go down. If I go down, for example, I won't find any because I've found C, so I marked C as found. Now I need to look for B, and B is nowhere here, and but I can't go back to B now because I removed it from Q. Yeah, we burn your bridges. Yeah, because they were remember we can't go back to B now, so we can't explore this path anymore. So maybe we don't need to pop pole. We just need to peek. You're peeking, right? Yeah. I think that solves it. So if here, 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 once we have checked vertically and horizontally, then I think it's a good idea to just remove. But no, Q is first in first out. I think it's okay. It's okay if we do this. Once the size of Q becomes equal to the size of word, I think we have found our answer, right? So I can say if Q dot size is word dot size will return true or return false. 29 minutes. We never used this. We never used set. No. Yeah, but there is a problem here. We need one more condition here that that index should not be in the shouldn't be in the our set. You see, it shouldn't contain set dot add new int new r new c. So far looks okay. No, index. Word index. Int word index 1. Now we also need to check that word index index bound. So see, there are a lot of things to check, and word index smaller than word dot size. There are a lot of holes in this code. Word 0. What's that? Get character at zero. Choret. Peak. Oh, cannot find the symbol. What symbol? What index? Oh, okay. Is this symbol? Word. Method size. Word size. Word size. What? It's a string. So what's wrong with size? variable word of type string cannot find symbol. This is it length. Index, 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 index. Oh, this index. Or index. Length. Should be true. Now I can see why depth first search would be a better option. In depth first search you get a better, you get a natural sense of things being incremented. Like in each call, okay, you know, A, B, B, C, C. What's the problem? What's the problem? Why is... Okay, let's look at the contents of the queue. Print queue. Set system dot out dot print set. What? What? Queue size. Queue size. Queue size remains 3. Queue size remains 3. This code is so bad that I don't even like. I'm not even feeling like debugging it. This is a very bad solution. Well, these two things are already in the queue. This A and this A is already in the queue. That already that already makes this thing illogical. Yeah, we shouldn't be doing this. Instead, we should have a kind of a, we can simply say, well, if new word. If word index becomes word dot size -1, then we have found the entire word. Word size. Time limit exceeded. Okay. Okay, let's see. C. Let's see. The first letter is C. So there would be two S in the queue. We would start with this one. We look up, right, up, down, left, right. Okay. This S gets pulled off. Okay, we remove this S after looking in 4 directions. Then this S. Pick this newer. Well, system.out.println. I just want to see what indices made it till this point. Is it 9? Yeah. Zero, 1, 2, 3. 0, 1, 2, 0, 1, 2, 1, 2, 3. 2, 3, that's right. And then for some reason 0, 3, 0, 3, 0, 1, 0, 3. What's 0, 3? Are we checking the directions right? 0, 0, -1, 1, -1. 0, 3. 2, 2, 0. 2, 2, 2, 3. 2, 2, 2, 3. Okay, this is the problem. Okay, so we don't need a hash here, we need a array. Visited new int array import dot length plus 1, or simply this board length. And visited new R, new C, should not be, well, should not be 1. Visited new R, new C, 1. Because by default values in the array are 0. Time up, time up, time up. See guys, this is what happens when you don't like plan it well. This is my last solution. It was a fail. I tried doing something similar here too. But yeah, this is a very good approach, by the way. Yes, yes, yes. You can try this. Q, but no. Okay, let me see the proper solution. Okay, it's kind of long. DFS. Look at how easy the solution is. Okay, we're finding the initial, then we are actually manipulating the input matrix for well, we don't need to keep visiting array. If we have already visited this, then we are returning false, and this is typical F search, exploring all the 4 directions. If any of the we found path in any one of these, we simply found it. And what's this? TMP. What's TMP? Okay, we are marking it back because we okay. Okay, very easy. Why is it such a word? We kinda Definitely, I will try this again in a couple of days now. Okay. Yep. Good problem. Next problem. Trapping in water. Given